This is topic 33, rates of change. So we all know that the average rate of change is the change in y over the change in x. Now, the instantaneous rate of change is the derivative of y with respect to x. Right? Remember, this would be like a secant line, if you will, the slope between 2 points, and this would be the slope of a tangent line. But anyway, we're going to go ahead and go on to example 1. Now it says, assume that the displacement at time t of an object moving along a line is given by the function s of t equal to 3t cubed minus 40.5t squared plus 162t for t on interval 0 and 8, and it includes 0 and 8. So the first thing we're going to do is we're going to find velocity, speed, and acceleration functions at time t. So to figure out the velocity at time t, we're going to take the velocity is the derivative of the position function. So we're going to take the derivative of this, all right? So that would be 9t squared minus 81t plus 162, all right? Now, for speed is the absolute value of the velocity, right? So this is what it's telling you. It says speed is how fast something is going regardless of its direction. So the speed is the absolute value of 9t squared minus 81t plus 162. Okay? So finally, we're going to look for the acceleration. So the acceleration is the derivative of the velocity, or you can call it the second derivative of the position function. So again, the acceleration is the derivative of velocity. So the derivative of velocity right here would be 18t minus 81, and then the derivative of 162 is 0. All right. So that's it for that one. Let's move on to example number 2. They're asking me to find the displacement of an object. All right, so the displacement of an object is basically from the starting position to the ending position. To be precise, is the final. I always call it the final position minus the initial position. All right, so in this case, we're going to use the position function, which was given to us in example 1. All right, I'm going to figure out, notice that I'm plugging in an 8 because it's giving me this interval right here. So this 0 is the initial time and 8 is the final time. All right, so if I have s of 8 minus s of 0, notice that I'm using 0 because that's the initial time. Now, to get s of 8, or the position function, the position at t is equal to 8. I have to go back to this original function and plug in an 8 here, here, and here. Okay, so I would have 3 times 8 to the third power minus 40.5, 8 to the second power plus 162 to the power of 8. Sorry, times 8. So this right here would be 240, and s of 0 would be 0. Again, if you plug in a 0 into the displacement function, you get 0. So this would be 240 minus 0, which is just 240. All right, so the displacement of an object from the starting to its ending position would be 240. Not a huge deal here. Now, to describe the motion of the object, we will not use the position function, because the position function does not really tell us if this object is retreating or advancing. What will tell us that, though, however, is velocity. This is 9t squared minus 81t plus 162. And remember, this is what I got from taking the derivative of the position function. Now, it's written right here for you, but if the velocity is greater than 0, which means if the velocity is positive, then the object is advancing or going up or going to the right, according to whatever problem you have. And if the velocity is negative, the object is retreating or going down or going left. Again, just depends on what problem you have. So how I do this, how do I figure out where this is positive and this is negative? what I have to do is set this equal to 0. So I'm going to set this equation, this velocity equation, equal to 0. And then I'm going to sketch a graph for it. Okay, so I'm going to factor out a 9 here. And I have t squared minus 9t plus 18. And I'm going to factor this. So notice that the 9s really doesn't matter. I can divide each side by 9, and that 9 I'll get rid of it. So I will have t minus 6, t minus 3. So therefore, velocity is 0 at 3 and 6. All right, so that's going to be important because those are the roots of this parabola. So I'm going to sketch this parabola. This is 0, this is 8. Again, this is the velocity. Alright, so remember I chose those two numbers because that was the interval that was given to me at the beginning of the problem. Right, it tells me that the time where the velocity is 0 is 3 and 6. Alright, so those are the roots of my function. Notice that this is a parabola. And it's positive, so it's going to be concave up. So it has to, I don't know exactly everything about this, but I do know that it's going to look like this, right? Something like this. It's going to be a parabola opening up, concave up. So if you look at it, if I want to know when something's advancing, well, that's going to happen. The velocity is positive, which it is here, and the velocity is positive here also, and it's negative here. All right, so that's when it's retreating between here. So hopefully if that doesn't make sense to you, think about it. The position function, it doesn't matter. Position function, all that tells you is where that object is at a certain time. The velocity function instead, remember if it's positive, the velocity is positive, that means I have a positive slope, which means I'm advancing, all right? And if I have a negative for the velocity, which means is the derivative would be negative, which means the slope would be negative, which means I'm retreating. All right, so all those connections need to happen in your brain. So anyway, to finish this up, the question didn't ask for me to do a sketch. It's just asking me where is it advancing, where is it retreating. All right, so remember, if you're trying to figure out if it's advancing or retreating, you have to use the velocity function. So it's advancing between 0 and 3. Notice that the 0 has to be included. All right, like if I keep going this way, 0 would be the point, the end point there. But even at that point, you're positive. And between 6 and 8, again, 6 and 8 right here, so that's positive. And notice that I didn't include the 3 or 6 because at 3 and 6, the velocity is 0. It's not positive, it's 0. And it's retreating at between 3 and 6. All right, so you see that all of that's negative. All right, so that's that. So hopefully that makes sense. Now the next part says compute the total distance traveled. All right, so how you do that is that you're gonna figure out the position, the initial position, which we have already calculated was 0. All right, and I have to figure out the position at 3. Now I'm using 3, I'm also going to use 6 because remember, right there my velocity was 0. All right, so it means that this object, wherever it was, whatever direction it was traveling, it stopped right there. All right, so at 3, I need to figure that out. I need to figure out this position at 6, and I need to figure out the position at 8, which I already had. All right, remember from the example number 2, I think. S of A was 240. All right, so go back to your position function, figure those two things out. And I think perhaps this part could be the hardest part to understand. All right, so between 0 and 3, see, you can actually tell from here, between 0 and 3, this is not really the path. This is not really the path of that object, but what this tells you is that it was advancing. So between 0 and 3, you're advancing. All right, between 3 and 6, you're retreating. So this object kind of went forward, or to the right, if you will, if it's going that direction, stopped, and it went back. Okay, so that's where that came from. And then finally, between 6 and 8, 6 and 8, then that object, after it was going left, it stopped and it's going to the right now. So what you have to do is you have to find the difference between these distances, all right? And these distances cannot be negative. Remember, direction is irrelevant right now. I'm trying to figure out total distance traveled. All right, so the distance that this object, it was advancing between 0 and 3, and it traveled 202.5. It didn't really give me units, so I'm going to say meters. All right, on distance 2, it traveled from this point to that point. Now, between this point and that point, that would be 40.5. So again, there should be no negatives, right? I know that it went back. It was at distance 202.5, then it went back to 162, but the distance traveled was 40.5. And then finally, between 162 and 240, it traveled 78 meters or feet. I don't know what this is. All right, so finally the total distance would be distance 1 plus distance 2 plus distance 3. All right, so make sure that if you don't understand this part, you can come and ask me. But basically what you need to do is figure out the position at the endpoints, which are those two, and then figure out the position where the velocity was equal to 0, which in my case were 2 points. And then you're just getting the distances between those points, all right? Remember, no negative should be anywhere on here. All right, moving on for 5. It's asking me where the object is accelerating, where is decelerating. So I'm going to go back to my example 1 and figure out the acceleration, which I already did. And what I got was 18t minus 81. All right. Now, similar to the velocity, all right, if the acceleration is positive, then it's accelerating. If the acceleration is negative, then it's decelerating. All right. So what I need to do, therefore, is I need to set this equal to 0, and I need to solve. So I have 18t is equal to 81, so t is equal to 4.5. All right, so I'm going to sketch this now. I have between 0 and 8. Remember, those are my endpoints. And at 4.5, my acceleration is 0. All right, so now I need to go back here and be able to sketch this. Notice that this is a linear function with a positive slope. So a linear function with a positive slope needs to go through here. Okay, again, just to sketch, it doesn't matter. Again, it has an endpoint, so I guess maybe I should do that. Don't know, it doesn't keep going. All right, and right here you have negative acceleration, up here you have positive acceleration. Okay, so now, so it's as easy as that, really. Acceleration is between 4.5. Remember, 4.5 is not included because at 4.5 my acceleration is 0, and my deceleration is between 0 and 4.5. Right, again, 4.5 does not need to be included. So that's as easy as that. Now, on number 6 is asking me to describe when the object is slowing down or speeding up, and right here you can read, I'm sure, but try to make sure that it makes sense to you, and it should, right? If something is speeding up, the velocity and acceleration are going in the same direction, or basically that's what it says here. They have the same signs, right? If something's slowing down, the velocity and the acceleration are going in opposite directions, so, or have opposite signs. So if you think about it like this, like for example, if I throw a ball up in the air, even though as the ball is going up, it's got positive velocity, while its acceleration is negative because gravity is pulling down. So in that case, the ball should be slowing down, and it does. Okay? So to do this though, what we're gonna do is we're gonna sketch these two graphs on top of one another to figure out, to more easily figure out where you're accelerating, or sorry, where are you speeding up and where are you slowing down. So the acceleration, let's see, you have between 0 and 8, so I'm trying to make them the same size here. Let's say that 4.5 was right there, and this is negative and this is positive. All right, so, all right, speeding up means you have the same sign. All right, so it just depends. You could be speeding up in the positive direction, you could be speeding up in the negative direction. So speeding up, you can tell, for example, that all of this is negative and this is negative. So right here, this little sliver right here that's between my hands, I actually have both of those are negative. All right, so because of that, between 3 and 4.5. Okay, and it's also speeding up. This one's easier to see, I think. Between 6 and 8 and this part. So both of this parts are positive. So right here, between 6 and 8, you have both of them are positive. So between 6 and 8, and including 8. All right, that's they're speeding up. All right, slowing down. Slows down means you have the opposite sign. And notice that right here, for example, you have a plus and you have a minus here. So it's going to be slowing down between 0 and 3, or at 0 and 3, not including 3. And then between 4.5, notice you have a, wait a minute, 4.5 and 6. Oh yeah, you have opposite right there. You have a negative and you have a positive here. So between 4.5 and 6. Alright, so that's that. Okay, so finally it says, for what values of t is the average velocity equal to 0? Alright, so this is telling you this right here, which you can use from now on. If the average velocity equals to 0 when the position function and the starting functions are equal. Alright, so just to make sense of this, alright, let's go ahead and say average velocity is equal to the final minus the initial position, which we're going to call t naught, over time, right? And if I set that equal to 0, then you'll see that that's true. All right, so to solve for this, you can either cross multiply here, or you can multiply both sides times t minus t naught on both sides, and that would cancel. The point is that you should see how I got here, but if you still don't, just come see me. All right, so that's what I have, and if I add this to the other side, I have the final position equals the initial position. Or as your notes put it, the position function equals the starting function. So you have to have the initial and the final being equal. All right. So now what we're going to do here, so to figure that out in your problem, so if you have a problem, so this is just proving to you that this was true. Now to actually do this on the homework, right, or for a problem, what you do is you're going to grab the position function, and you're going to set that equal to 0. Okay? You're going to set that equal to 0 and solve. Now, on this one, so you're going to need a calculator, definitely. I mean, I don't expect you to do this without a calculator. So do this with a calculator, and on mine, it will look something like this. Okay, it will look something like that. So I'm trying to find the roots, all right? I'm finding the roots besides the t is equal to 0. I know there's a root right here. Yes, I know that, and because that's why my initial position happened, that's where that's going to happen, right? But so besides this one, I'm trying to look for another root, and if you look at the graph of this between 0 and 8, right, that doesn't happen. All right, so because it doesn't happen, this one, there is no values of t where the average velocity is equal to 0. Again, so hopefully that makes sense to you. What I'm saying is that where the average velocity is the same is where you have your final position and initial position being the same. And think about it, if the final and initial are the same, then that top of that would be 0, which will give you 0. All right, again, this could be slightly confusing, that last part especially. If you got any questions, make sure to let me know.